All right. Hey, what's up, everybody? Mr. Fortin here. My goal is to do a video of the classroom exercises that I signed over the weekend here. I only got 5% battery life yet, so I got to be quick because I also got to just upload it to YouTube. Anyways, check this one out here. Got number one here. The two segments are divided proportionally. That's nice, right? That means part to part is going to equal part to part. Those 2 points are dividing. That ratio here is going to be the same as this ratio. State several correct proportions. So you want to start with this one. I call this one the mother proportion, like the mothership there. And everything gets built off of there. So we know that that's true because u to v, I did large, there were parts, the smaller part equals the larger part, the smaller part here. Down to 3% already. Really? Already? Okay, do a mean swap. I didn't know that u to x equals v to y. That's also going to be true. So u to x over there is going to equal v to y. That larger part to larger part equals smaller part to smaller part. Okay. I do denominator add, for instance, u plus x. Okay, u plus x, which is that, equals y plus v. Which is that over y and x. I'm going to skip that one because that one's not really that useful. Denominator add here would be useful here. U plus v, right, the whole thing, and that would be w, okay, over v would equal x plus y over z. I got that y plus x here, right, over z. So x plus y is z, and that is over what do I had originally here, which is y, okay? So whole apart equals whole apart, right? W's the whole here, Z's the whole here, and you get the parts there. So those are several of the many that you can do here. You can also do whole to whole, right? W to Z would be in the same ratio as, for instance, U to X, okay? Whole to whole equals part to part. How can I justify that? Well, let's see here. I could do a mean swap there. Look, I can do a mean swap there, and then I'd have V over Y, which again is part to part, and then, so and in a different one, right? Here I can build it. So anyways, several things, right? Things that are sort of just logically match up are going to match up here. Here are four. I'd love to see what you can get, though, later. State several bullet proportions informally shown here. Lower left to upper right. Let's see here. Lower left to upper right. Upper left. That's silly here. So that would be lower right to upper right, okay? And then I could do whole left to lower left equals whole right to whole right to lower right. That would work too. I'm at 2% power, so there's really not much time left here. A whole bunch of things work with those. You can get several more. There are a lot you can do. Check this one out here. I think this is a good one here because if you know that this side here is 14, that side's 6 and 10, well, you don't know what x is, you don't know what y is here. You don't know what those two things are. But what you know here to do problems like this, to figure out what the top left and bottom left are, is you know that they're going to be a 6 to 10 ratio. So you can say that this is 6x and this is 10x right here. And, solve for x, figure out how long that is, because you can solve for this here. Check it out here, 6x plus 10x equals 14. Go ahead, solve for x, and then multiply it by 6. That tells you the top left. And multiply it by 10 tells you the bottom left here. That's kind of the fastest way you can do these problems here. I also know that 6 to 10 simplifies, right? My sort of scale factor top to, well, actually 6 to 10 to parts here, right? So it's not actually a scale factor. It's sort of the dividing proportionally here. It would equal 3 to 5, okay? So that's why we can do 3y. We can make 3y be the top left, make 5y be the bottom left here. And they need to add together to be 14 because you're given that entire left side is equal to 14 here, okay? So anyways, don't freak out about these classroom exercises. I think they just sort of are good to show you that there are a whole bunch of ways we can move around this sort of mother proportion of part to part equals part to part. We know all these other laws to say, you know what, it's actually part to part equals part to part, but it's also part to whole, right? 6 to 16 would be the same as 6x over here to 14, and you can solve for x that way. 6 to 16 here would be the same as 3y to 14. You can solve for y there, right? Because it'd be a 3 to 5 ratio. That's the way that I would do it rather than parts A and B, okay? 3y and 5y, why can they be used? Because it's in a 3 to 5 ratio by the basic proportionality theorem, okay? Anyways, hopefully you watched this. Hopefully this helped you. If not, we'll go over it in class on Monday. Have a good weekend, guys. 1% battery life left. Let's see if I can get it posted to YouTube.